All right, guys. So on number one, they give us ln4, which is 1.386, and ln6, which is 1.792. They give us this information right here. Our calculators, we actually have a log button right here, and we also have an ln button right here. So if you happen to have a calculator, even if you don't have a graphing calculator like this one, you do have the common log button, and you do have the ln button, the natural log button. Even if you're doing it on the scientific calculator on your cell phone, you should have the log button, the common log button, and the ln button. So if I were to do this problem on our calculator, ln of 4, you'll see that it does give you this value. Yeah? Could somebody do me a favor and type in on the calculator, type in ln and actually do ln of 24. Type in ln of 24 and we get what?
3.17.
178 what?
No.
78? 05. Okay, so let's just do it like that. 3.718. And we're going to put these squiggly lines, which means it's an approximation because we know the actual answer continues forever. Now, we already know the answer here, guys, because of our calculators. But what we're going to do is manipulate the 24 so that we could change it to a 4 and a 6. So 24 could be rewritten as 4 times 6. So this is what I want to do. I want to go ln of 24. I'm going to rewrite it as ln of 4 times 6. Now, using the properties that we have up on the board right here, we know that when you have something times something, you could split it and make it log of the first something plus log of the second something. So that's what we're going to use. We're going to use the product property right here to rewrite it as ln of 4 plus ln of 6. So now that we know, now that we have it expanded as ln4 plus ln of 6, and we already know they give us that ln of 4 is 1.386 and ln of 6 is 1.792, we could substitute those decimal values and say that we have 1.386 plus 1.792. And of course, if we add those values together, we really will get the answer 3.178 right there. Okay? So you're probably wondering, why the heck are we doing this? In reality, the only purpose of doing this is to be able to practice expanding logarithms. Okay, so we're doing it to practice expanding logarithms. So let's go back to this. Number 2, we want to just rewrite 36 as either a 4 or a 6. How are we going to rewrite it as? You could change it to ln 6 squared. Or you could also change the ln of 6 times 6 if you wanted to. But I'm going to go ln 6 squared. Why? Because I'm going to use the power property. Power property is right there. And what does the power property say? You could take that power and put it out in the front, or if you're condensing, you could take it from the front and put it up as a power. So in this case, we are going to take that power and move it out to the front. So I really have 2 times ln of 6. I don't know why I put it in parentheses. But ln of 6, we already know, is 1.792. So if we take that 1.792 and plug it in there, and we multiply 2 times 1.792, we will get our final answer. Right? Could somebody do me a favor and actually type in ln of 36 in the calculator? 3.5 what? Okay, so we'll just leave it there, right there, 3.583. And if we did take the 1.792 and plug it in here and multiply it by 2, we should get that same exact answer. Okay, so the whole purpose of this is just to manipulate numbers to practice expanding and condensing. So number 3, it says ln of 9, and I put challenge because it's challenging. We need to think how we could manipulate 4 and 6, some mathematical combination with 4 and 6 to get 9, okay? And does anybody have that mathematical combo with 4 and 6 to get 9? Anybody? I want to pause it and wait to see if somebody gives me an answer. All right, thanks for the answer. What is it? 36 divided by 4, right? So if we want to change it in terms of purely 6 and 4, we're going to change it to ln of 6 squared divided by 4. Now again, the whole purpose of this is just to be able to practice expanding. So if I wanted to expand this guy right here, we're going to have to use the property of which one? Quotient. So if we look at the properties, we know we have a fraction, so we're going to use the quotient property to expand it and put a minus sign between it. So let's do that. Let's expand it and put ln of the top, which is 6 squared, minus ln of the bottom, which is 4. And of course, this power could also be expanded out here to the front because of the power property. So my final answer will be 2 times ln of 6 minus ln of 4. Now you're probably wondering why I'm putting them in parentheses, because the whole purpose of this is to be able to use the decimal values that they give us, and they do give us the decimal values of 1.386 and 1.792. So then it just becomes a question of substituting those values into those parentheses. So you're really going to have the ln of 6, which is 1.792, and the ln of 4, which is 1.386. So if we did multiply 2 times 1.792 and then subtract 1.386, we'll get our final answer for number 3. But of course, it's kind of all pointless, because if you have a calculator and you just type in ln of 9, what do we get? Type in ln of 9 on the calculator, what do we get? 2.197? And that would be the same answer as we'd get over here if we were to multiply, if we were to multiply 2 times 1.792 and then subtract 1.386 from it, we'd still get that same value. So let's move on to something more important, something more fun, expanding and condensing. So let's take a look at number 4 and expand that. And of course, we're going to be using the properties. What property are we going to use first? Quotient property. So let's do that. We're going to have ln of the top, which is 5x squared, minus ln of the bottom, which is 2y. And now from this point, we need to take a look at the first term right here and think, is there anything else I could do? Is there any other properties I could apply? The product property and the power property. Now, a lot of people get confused and do the power property first, because in PEMDAS, you do exponents before multiplication, but that doesn't work here, because when we think about this, if we were to move the 2 out to the front and then separate the 5 and the x, the 2 ends up being with the 5, and we know that the 2 doesn't belong to the 5, it belongs to the x. So that is why I'm going to focus in on product property first between the 5 and the x. So I'm going to have ln of 5 plus ln of x squared. Is everybody with me? And of course, I'm also going to bring down this minus ln of 2y. What do you guys think so far? Yes, I get it. Okay, so we're going to move on, and we're going to continue to expand. Now the question is, there was product property here, and as a matter of fact, there's also product property over here between the 2 and the y, isn't there? Now this is the most trickiest part of expanding or condensing, because when we expand, I'm going to take this ln and I'm going to expand it, write it twice. But keep in mind that there's a minus sign right in front of it, right? This minus sign belongs to the whole thing. So the best thing to do is to recognize that that minus sign belongs to the whole thing. So I'm going to put parentheses around it. So when I do expand it and make it ln of 2 plus ln of y, I still have that minus sign out in the front, because I'd have to still distribute it to both terms to be able to change both of them. If you don't put those parentheses, you'll probably just leave it as ln of 2 and get it wrong, because this also needs to be a minus. So let me bring down the rest. I have ln of 5, I have plus ln of x squared minus parenthesis ln 2 plus ln y. And of course, let's distribute that minus sign, and let's also use the final power property to take that 2 and put it right here in front. So let me write my final answer here. It's going to be ln of 5 plus 2 ln of x minus ln of 2 minus ln of y. And that is the final expanded form of the above, which is ln of 5x squared over 2y. I hope you guys get that. And if you don't, watch it on Edmodo, right? To be honest with you guys, expanding is really just practice to get better at condensing. So let's go to number 5 and let's condense. Well, we do see that there's a 3 times, which means we could use a power property. We have a minus sign, which we're going to use a quotient property, and a plus sign, which we're going to use a product property. So I'm going to begin with the power property. This 3, I'm just going to move it up to the top. So I'm going to take the 3, move it up, and make it a power of x. So I'm going to have log base 2 of x to the third. And I'm going to rewrite everything. I'm going to bring down the minus log base 2 of y plus log base 2 of 3. And now we could focus in on the subtraction part or the addition part. Now remember, this one's a quotient, this one is product, and when you think about division and multiplication, you just go from left to right, okay? So I would take this one and use the quotient property to bring it together. So we're going to have log base 2 of something divided by something, and we get the top part with the x to the third, and we get the bottom part with y. So we're really going to have x to the third over y. That looks like a 4. It's supposed to be a y. Any questions so far? We're going to bring down the plus log base 2 of 3. And now we're going to use the product property because we have a plus sign right here. We're going to put them together as one single logarithm. So we're going to have log base 2 of this guy times this guy. So let me actually write that out. I'm going to write down x to the third over y times 3. And when I multiply a fraction with the number, I put it over 1. That way I could multiply the top with the top and the bottom with the bottom. And the final answer will be log base 2 of 3x to the third over y. And I would put that fraction in parentheses. So right there we condensed. Okay, we're going to take a look at the last one, and I need to do it in under 40 seconds, so I'm going to be making it quick. Since we have parentheses, we're going to do what's inside the parentheses first, and we're going to condense using the product property. And that would be taking this ln and this ln, writing it as one single ln, and multiplying y times 5 and getting 5y. Now, of course, we still have the minus sign. We still have the 2 ln of x, and we don't even need those parentheses anymore. But I will take this 2, raise it up to be the power, so I'll have ln of x squared using the power property to condense, and then minus ln of 5y. And the final thing to do would be to apply the quotient property, getting a single ln of the x squared over the 5y. And that is your final answer there.